This lesson is for Advanced Algebra, Lesson 10.9 on radians. A radian is something that you're probably already familiar with because when you measure the length around the edge of a circle, you're used to calling that the circumference of the circle. Only now we're going to refer to that from now on as the radian measure. When you measure length on a curved surface, that's very difficult to do. Back when you first learned about measuring a circle, or the length on the edge of a circle, back in geometry, you referred to that as circumference, and the formula you would have been using was 2 pi r, or pi times diameter. Well, the unit circle that we're using in chapter 10 has a radius of 1. So if we're talking about 2 pi times 1, the length around the edge of the circle is simply going to be 2 pi. Now we're used to talking about going all the way around the circle in degrees as being 360. So you need to know that the length around the edge of the circle is 2 pi radians, which is the same as going around the circle in degrees, 360 degrees. Now because those values are equal to each other and because they're both even, we're going to get rid of a 2 on both sides. So if I divide both sides by 2, I end up with pi equals 180. Which makes sense. If all the way around the circle takes a length of 2 pi, halfway around the circle is only going to be 1 pi. So let's have you grab your unit circle right now. Let's start filling in some of those values. So if you grab the unit circle that we've been working with during chapter 10, we're going to go to our starting place at 3 o'clock, and let's fill in the radians on the outer edge here. So start here at 0 radians. Go all the way around the circle, you're gonna come back to where you started, and that would be 2 pi radians. If you only go halfway around the circle, that's going to be the same as pi radians, or 180 degrees. Now let's keep going with that idea. Halfway around the circle is pi radians. What's halfway to pi? Well, that would be a quarter of the circle, or 90 degrees, so that's going to be pi over 2 in radians. So halfway to 180 would be pi over 2. Let's do one more step there. If we went halfway to pi over 2 or halfway to 90, we'd be here. Halfway to pi over 2 is going to be half of that, and that would be pi over 4. So those are the values that we're going to be working with in lesson 10.9, because those values are the length around the edge of the circle rather than the degree measure that gets you there. So there's going to be other radian measures that we're going to fill in. But I want to show you first how to convert back and forth between degrees and radians. So when you convert back and forth between degrees and radians, you're going to utilize this idea that pi and 180 are the same value. They're just measured in different ways. So if you're trying to get from degrees to radians, you'll multiply by pi over 180. We're going to turn this into a fraction. Now I want radians, so that's why the pi shows up on top. 180 is a degree measure, and I want the degrees to go away, so I put the degrees on the bottom. So let's take 45 and multiply it by pi over 180. That should turn it into a radian measure, or a measurement of length. If you multiply fractions, take the first number and turn it into a fraction by multiplying straight across. So obviously here we get 45 pi over 180. Now let's talk about reducing that fraction. There's lots of different ways to reduce fractions. In this particular fraction, the numbers end in 5 and 0, so that means 5 is a common factor. So if you divide both numbers by 5, you get 9 pi over 36. Now I had to use a baby calculator to help me with that, and you might have to as well. I knew 45 divided by 5 by heart. I did not know 180 divided by 5 by heart, so I just typed that in real quickly on my calculator. Now 9 pi over 36 can be reduced even further. If you add up the digits here, 3 plus 6, you get 9. If the digits add up to a 9, that means 9 is a common factor. And 9 would obviously be a common factor with itself, so 9 can divide into both of these. So we get 1 on top, or just 1 pi, and 9 goes into 36 4 times, which is pi over 4, which is what we got before anyway. We had already said that 45 degrees is the same as pi over 4 radians. So let's try it one more time with one that we don't know. Let's convert 210 degrees into radians. So I take 210 and I multiply by pi over 180, because the degrees up here and the degrees down there are going to cancel each other out. So I end up with 210 pi over 180. Now again, a trick for you in terms of reducing. If both numbers end in a 0, that means 10 is a common factor of both. If you divide them both by 10, the zeros are going to cancel. So now we end up with 21 pi over 18. 21 and 18, if you add those up, 2 plus 1 is 3, 1 plus 8 is 9. 9 and 3 both have a common factor of 3, so 3 is a common factor of both of these. So 3 goes into 21 7 times, 3 goes into 18 6 times. So 7 pi over 6 is the radian measure of 210 degrees. So let's go ahead and put that in. 210 is the first click in quadrant 3, and that is 7 pi over 6. So that's converting degrees to radians. You multiply by pi over 180 because we want the degrees to cancel, so we put the degrees on the bottom. We want radians to be our answer, so we put the pi on the top. When you want to go the other way, you just flip the fraction over. If I want degrees and I want the radians to go away, I put the pi on the bottom. So now we're going to multiply by 180 over pi. So 2 pi over 3 is a radian measure, and I want to know where that is in degrees. So I take 2 pi over 3 and I multiply by 180 over pi. I want the pi on the bottom because now that pi and that pi are going to cancel each other out. Pi divided by itself is 1, so that's going to go away. You have the option here now when you simplify to either multiply across and then divide, or you can do some simplifying, which would be dividing first and then multiply. I like doing dividing first or simplifying first, so I'm going to demonstrate that step. 3 goes into 18 6 times, but because this is a 180, I just put an extra 0. 3 goes into itself once. I've got nothing left to simplify, so I'm just going to multiply straight across. 2 times 60 is 120, so 2 pi over 3 radians is the same as 120 degrees. So let's put that on our circle. 120 is the same as 2 pi over 3. We've got one more in this section to try, 3 pi over 4. Let's turn that into degrees. 3 pi over 4 gets multiplied by 180 over pi because the pi's cancel. 4 and 180 are both even, so that means 2 is a common factor. So I'm going to divide both these numbers by 2. And now I'm going to multiply straight across. 3 times 9 is 27, but there is a 0 there, so it's 270. I still have a 2 on the bottom. If I cut 270 in half, I get 135. Again, I used a little bit of calculator help to get some of that work done. So 135 degrees is the same as 3 pi over 4 radians. So 135 is the same as 3 pi over 4. So now let's summarize a little bit of what we just did. We're not finished yet, but I want to help you clarify what has just happened. When you're converting between radians and degrees to radians, put what you want on the top. So if I want degrees, I'll multiply by 180 over pi. If I want radians, I'll put the pi on top and put the degrees on the bottom. So the one that you want should be on top. Degrees, if that's what you want, put 180 on top. If radians is what you want, put the pi on top. So let's go ahead and finish our unit circle in radians now. I'm just going to give you the rest of those values. So I've got them here listed in green for you. You can go ahead and finish those off on your circle. Here's quadrants 1 and 2. I would recommend that you get quadrant 1 memorized. 30 degrees in radians is pi over 6. 45 degrees in radians is pi over 4. 60 degrees in radians is pi over 3. We already talked about pi over 2 being 90. We already calculated 2 pi over 3 for 120 and 3 pi over 4 for 135. So the only other one we didn't know was 5 pi over 6 for 150. Now I want to look at this for a moment because I want you to see that the numbers do make sense. If I take pi over 6 and 5 pi over 6 and add them together, adding fractions means you have to have a common denominator, and I do here. So the bottom number stays at a 6. 5 pi plus 1 pi ends up being 6 pi. 6 divided by 6 cancels, so I end up with pi there. Isn't that true if I did it in degrees as well? 30 plus 150 is 180. So the numbers here make sense. They're not just arbitrary. These will add up to 180, which is the same as pi radians. So let me go ahead and display the bottom half of the circle for you so you can get the rest of your radian measures listed on your circle. You do not have to memorize the radian measures as long as you know how to convert quickly and easily. Like I said, I do have quadrant 1 memorized, and I would recommend that you do that. I would also recommend that you memorize the compass points in radians. So pi is an easy one to remember, that's 180. 270 is another one that makes a lot of sense. It's 1.5 pi's around the circle. 1 pi to get to 180, and then another half pi, so that's 3.5 pi, or 3 pi over 2. And then when you get back to the beginning, it's total of 2 pi. So then there's the rest of your radian measures for you to fill in so that you have those as a reference on your circle. One more thing to mention here, and then we're going to look at some graphing. If you're asked about a circle that has a radius other than 1, just make sure to multiply your answer by the radius length. Remember that we're doing problems that are 2 pi times 1. So if they give you a circle that doesn't have a 1 for the radius, you're just going to have to take your radian measure and multiply by whatever that radius is. The last thing I want to look at with you today is graphing with radians. When we originally did graphing of cosine and sine, we did it in degrees with all the compass points. So let's review the compass points in radians this time. 0 radians is the same as 0 degrees. The next compass point is at the northernmost point of the circle. We called that 90 degrees. In radians, it's pi over 2. The next compass point is at 9 o'clock. We would have called that 180 degrees. In radians, that would be pi. 270 is our next compass point, which is down at 6 o'clock on the circle. And in radians, that measure is 3 pi over 2. When you go all the way back to the beginning, you have traveled a total of 2 pi radians. So if we go around the circle now and do the cosine as we travel around the unit circle, you'll notice that regardless of whether we're in degrees or radians, we're going to get the same results that we did the first time we graphed. The cosine at 0 radians is the cosine at this location, which is still 1, just like it was before. If we travel up to 90 or pi over 2 radians, the cosine there is going to be 0. The cosine at pi or 180 is -1. Cosine down at the bottom here at 270 or 3 pi over 2 is 0. Back to the starting point, we get back to 1. So if we graph it, it should look exactly the way it looked the first time we graphed. It starts up at 1, travels all the way down to -1, and then travels back up. It looks like a V initially, but know that it is a sine wave, so we want to make it look like a curve. And we want the curve to be as symmetrical as possible. The only change to this graph is going to be where it crosses the x-axis. When we graphed the first time in degrees, it crossed at 90 and 270. Now it's going to cross at pi over 2 and 3 pi over 2. The only other difference is going to be what the period of the graph is going to be. Period means how long does it take the graph to repeat. Originally we learned that that value was 360 if we were doing it in degrees. Now if we talk about how long it takes for the graph to repeat in radians, hopefully you know that that answer then is 2 pi. Let's do the same thing now for sine. If we fill in the compass points there, the compass points are going to be the same, only now they're going to be in radians. Hopefully you remember the values for graphing sine. Sine starts at 0, goes up to 1, down to -1, and then back to 0. So the sine graph looks like a true sine wave. It starts in the middle, comes up, goes down, and then back up. And the period of the sine graph is also going to be 2 pi.